How can a function fail to be differentiable at a? So we have three cases when we have a function has at a is have a corner at a, like this. The example is like an absolute value, or discontinuity, or vertical tangent. The reason why for the corner is the function is not differentiable because at this point we have so many ways to draw the tangent line. And of course we learned in the theorem before the function is differentiable if then it is continuous. So that means that the function is not differentiable, it is not continuous. So the discontinuous function is not differentiable. And for the last case, vertical tangent. So you see at A, we draw the vertical tangent. And the vertical tangent has the slope of undefined. Okay, so that's why it's not differentiable at A. Another way for us to look at differentiable is that if you take a point A and then if you zoom out, then this part it will become like a straight line for the point A right here. So then it will be differentiable at A. But right here, the corner, if you zoom out, then the corner is still the corner. It doesn't look like a straight line. So that's why it's not differentiable at A. Higher derivatives. The second derivatives, we have the notation is f prime and then prime, or you said f double prime. Or you use the Leibniz notation is that the first one is the derivative of, and of the first derivative, so we got the second derivative. Example number 6, we want to find the second derivative. So from the example that we learned before, the first derivative of this function is 3x squared minus 1. So this one is from example number 2. Okay, so if we take one more time the derivative for one more time for this function, we will get the second derivative. By definition, it will become the limit h approaches to 0 of f prime of x plus h minus f prime of x divided by h. Now we will plug in for the f prime of h. So we got 3x plus h squared minus 1 minus 3x squared minus 1 over h. Now we will open the parentheses, right? So we got 3x squared plus 2xh is going to become 6. And then plus 3h minus 1 minus 3x squared plus 1 divided by h. So we have some to cancel. Like terms, we collect like terms, right? And 1 and 1. And on the top, we can factor out the h. So we got 6x plus 3 divided by h. We can cancel out the h now, and we got the answer is, this is 3h squared. So we still have 3h. So we can cancel the h now, and then we plug in the h. Then it's 6x plus 3 times 0, and the answer will be 6x. So f the param of x is 6x, and what do we see about this? This is the a line, right? It's a linear equation. Example number 7. If the f of x is x cubed minus x, find the f the param of x and triple param of x and x the fourth term of derivative of x. So let's write out everything again. So we have f prime of x is 2x 3x squared minus 1, and we just found that f the param is 6x. So we can apply the same definition one more time to find the limit and so on, the same like before. But if you notice that this is a line, okay, already, so f the param is a linear equation. So f triple param, the definition of the derivative is the slope of the tangent line, and this is already a line, so the tangent line to that curve will be itself. So the slope will be 6, and this is also a line, but it's horizontal line. So if you take the one more derivative for one more time, then we will, this is the slope is like the horizontal line like this. The tangent line will be the same as this line, and the slope of the tangent line is the derivative. So the slope of the horizontal line is 0. So I know that the answer for this will be 0.